Welcome back to Low Stress Math with Mrs. Bono. We are in Unit 4, Functions, on Lesson 8, a little more on linear versus nonlinear. Now, if you remember, linear means its graph is a straight line. Nonlinear means its graph is not a straight line. So, a linear function is a function in which the graph of the solution is a straight line. And a linear function has, do you remember back in 7th grade where you talked about slopes and constant rate of change? That's what a linear function has, a constant rate of change. Nonlinear functions, the graph of a nonlinear function is not a straight line. And nonlinear function has a rate of change that's not constant. So, for instance, this first graph here, it's constantly going up at the same angle. That means that this is a linear function. But this one, well, it's going down, and then it gets steeper, and then it hits rock bottom, then it starts to climb back up, and then it gets steeper again. That's not constant. That's constantly changing. That is nonlinear. Now this one, it's not even a function, but obviously also nonlinear because it's going in a circle. This one, also not a function because it fails the vertical line test, but also definitely not looking like a line. All right, how about we look down here now? Ah, that's a line. That is constantly going to the right, not up or down though. But that's still a line, it's still linear. Oh, this one's going down and going up, but that's not constant. It's on a curve. Curves are not linear. That's kind of, no, non-linear. How about this thing? Ugh, not even a function. That's ugly. That is non-linear. What about this thing? Oh, it's a line. It's going up and down, so it's linear. But it's not a linear function. It's just linear. I'm going to write non-function down here. So it may be a line, but that's not a function. All right. Are the following tables linear or non-linear? Well, we're looking for a constant rate of change. So I'm going to look for the change in x and the change in y. And I'm looking for it to be constant and the same. But I also know me, and yeah, I am going to divide this up a little because if I don't, I'm going to end up making a mess out of my paper and writing all over the place. So just let me divide that up. Probably should have done it on your papers too. And now I'm looking for the difference between the x values. Now in Greek, that little triangle is called a delta, and that means difference. So I'm looking for the difference in the y values and this little delta difference in the x values. So let's start with the x values in problem A. So I'm looking for the difference between the x values. So what's the difference between 1 and 2? Well, I'm adding 1. And the difference between 2 and 3? I'm adding 1. So my difference is constantly 1. So that is a constant x value. But now I got to look at the y values. And let's see what the difference there is. Well, the difference between 10 and 4 is negative 6. And the difference between 4 and 2 is negative 2. And the difference between 2 and 4 is positive 2. And the difference here is positive 6. And that's not a constant rate of change. That's a constantly changing rate of change. So this is nonlinear. It does not have a constant rate of change. It does not have a constant rate, not linear. All right, let's look at this one. Well, starting with the difference between the x values. Well, from negative 5 to negative 4, I add 1. From negative 4 to negative 3, I add 1. 3 to 2, I'm adding 1. Negative 2 to negative 1, I'm adding 1. Those are going up constantly by 1. Well, that's good. What's the difference in my y values? Well, negative 2 to negative 1, I'm adding 1. Negative 1 to 0, I'm adding 1. Oh, wait, look at this. My difference is always 1. The difference in y's and the different, it's a constant rate of change. So this one is linear. It has a constant rate of change. All right, let's look at C. C, well, let's look at the difference in x values. Negative 1 to 0, I add 1. 0 to 1, I add 1. 1 to 2, I'm adding 1. 2 to 3, I'm adding 1. So far, so good. My x values are constantly going up by 1. But what about my y values? Y. Negative 1 to 0, I'm adding 1. 0 to 1, I'm adding 1. 1 to 2, I'm adding 1. 2 to 3, I'm adding 1. Oh, look at that. It's a constant rate of change. So this is linear. It has a constant rate of change. All right, and D. Okay, the x values, delta x. The difference in the x values from negative 3 to negative 2, adding 1. Negative 2 to negative 1, adding 1. Negative 1 to 0, adding 1. 0 to 1, adding 1. Okay, so far so good. The x's are being constant in all of these. That's good. Now, what's the difference in y's? 6 to 1, that's subtracting 5. 1 to 0, that's subtracting 1. Oh, it's already no good. Now I'm adding 1. Now I'm adding 5. Bah! That is nonlinear. It does not have a constant rate of change. Well, that's not very good, is it? All right, so the constant rate of change is linear, and if it does not have a constant rate of change, it is non-linear. All right, let's just look at functions. Remember, in order to be a function, what does it have to have? Well, to be a function, you have to have x values that do not repeat. So I'm just going to remember that up here. Functions have x values that do not repeat. So let's look at the different things. This is a table, and I have 2, 4, 8, 12. Well, none of those x values repeat, so this table is a function. Now this, it looks like a table, right? Except it's split and it has some arrows. That makes this mapping notation. Let's see. Oh dear. I'm grabbing this because look, here, this 3 is going to 4, but it's also going to 2. So if I was writing it as ordered pairs, it would be 3, 4, and it would be 3, 2, with my x value repeating. It's not a function. I just realized it said circle the relations that are functions. This one gets a circle. That does not. Now these are graphs, and I'm going to bring your brain back a little bit to the vertical line test. Remember the vertical line test? If you can draw a vertical line, and let's just trace one of these lines that's already here, and it touches the function twice, that is not a function. This is a non-function. And what about that? Well, I could trace every single one of those vertical lines and it wouldn't hit. That's a function. Now look at these. E and F. That is ordered pairs. Those are ordered pairs. Remember when you write it like a coordinate for a point, that's an ordered pair? Let's look at these ordered pairs. My x values are 1, 5, 3, and 5. Oh dear, 5 repeats. This is not a function. It's not a function because my x value 5 repeats. How about this one? Well, let's look at those x values. 1, 5, 7, and 8. Well, none of those repeat. That's awesome. This is a function. None of my x values repeat. Okay, complete the table and graph the solution to the ordered pairs. Ugh. Okay, just a little reminder on some of this here. This is the domain. This is the rule. This is the range. And these are ordered pairs. And you graph the ordered pairs. So the rule here is -3 times x plus 1. And my domain, as always, is going to have some negatives. -2, -1. I like 0, but it also has some positive. +1, +2. So now I have to multiply -3 times -2, which is +6, plus 1 is 7. So my first point that I have to graph is -2, +7. All right, now it's -3 times -1. That's +3. 3 plus 1 is 4. So the next one I have to graph is -1, +4. Now, -3 times 0 plus 1. 0 plus 1 is 1, so I'm graphing the point 0, 1. negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. So now I'm graphing 1, negative 2. Negative 3 times 2 is negative 6. Negative 6 plus 1 is negative 5. So I'm graphing the point 2, negative 5. All right, now I'm going to come down here and we'll graph a few points. I'm hoping you can see the... So, first point, negative 2, positive 7. Negative 1, negative 2. 1, 2, 3, 4, 5, 6. My first point. Negative 1, positive 4. Negative 1, 1, 2, 3, 4. 0, positive 1. Right there. Positive 1, negative 2. Positive 2, negative 2, negative 3, negative 4, negative 5. Okay, when you connect the points, and look, I'm going to hold my ruler so that it's not going to move. I'm going to push into the ruler, start above the graph, go through all the points and below the graph. Arrows on both ends, because I could pick any numbers and it would continue on forever and ever. And now I write my original rule from up here down on here. So y equals negative 3x plus 1. Not too bad. All right. My rule for over here is negative x minus 2. But in between this negative and x is really a 1. So what I'm doing is multiplying negative 1 times my x values. Let me pick some x values here. Same ones as before. Negative 2, negative 1, 0, 1, 2. But now it's going to be negative 1 times negative 2, which is positive 2. 2 minus 2 is 0. So my first point is going to be negative 2, 0. Now, negative 1 times negative 1, well, that's positive 1. 1 minus 2, let's see, what's 1 minus 2? Negative 1. And that's going to be negative 1, negative 1. Okay. Negative 1 times 0. Well, anything times 0 is 0. Minus 2 gives me negative 2. And now I have the point 0, negative 2. Oh, I forgot to write the negative 1. That would have been bad, huh? Negative 1 times 1 is negative 1. Minus 2. Negative 1 minus 2 is negative 3. So I have the point 1, negative 3 to graph. Okay. Negative 1 times 2 is negative 2. Negative 2 minus 2 is negative 4. And I have 2, negative 4 to graph. Okay, that shouldn't take too long. Let's, you know what, let's keep graphing in pink. I think it's pretty easy to see when you're graphing in a color. Let's try this. Negative 2, 0 is on the line. Negative 1, negative 1. 0, negative 2. 1, negative 3. And 2, negative 4. Wow, those points are very close together, aren't they? Well, I know that a lot of people, when they graph points, they just want to graph the points that they have. But no, you have to graph all the way across the entire grid. So hold your fingers far apart, and you're going to push into the ruler, connect all those points, and go past the grid on both sides. Arrow and label. Y equals negative x minus 2. My x does not look very xy. There we go. All right, well, have a great day, and I will talk to you soon. Goodbye.